Hey, this is Chemistry Chapter 8 review. The purpose of this review is so that you can work the extra practice problems from the book in case you have forgotten how to work these over the Thanksgiving break time. Um, in the file section on Microsoft Teams, go ahead and print that paper off, or you can just look at it on your screen if you want. But these are the problems that I will be working through, and what you will need is your periodic table. All right, I do want you to write these notes down, all right, for your notebook. And the periodic table, I've gone ahead and labeled the columns 1 through 8, so that might also help you. So I printed out so that you could see it on the video a larger font. And we're just going to be working problems 1 through 8. Just the chapter 8 problems. We'll work the rest of the problems on the sheet on a video that I will upload tomorrow. So the first one says, give the chemical formulas for beryllium fluoride, potassium chloride, lithium phosphide, barium nitride, aluminum iodide, and iron 2 nitride. Okay, so first one is beryllium fluoride. So I wrote that as A. Beryllium's here in column 2. So if it's in column 2 and it's a metal, it wants to give up 2 electrons so it can be like helium. So if it gave up 2 electrons, it would have a 2+ charge. Fluorine, all the way over here in column 7. Okay, so it wants to gain an electron to be like neon. All right, if it gains an electron, it'd have a -1 charge. After you pull the big switcheroo there, okay, you would have a formula of BeF2 for beryllium fluoride. All right, potassium chloride. Potassium is here in column 1, so it would like to give up that 1 electron and have just a plus charge. Chlorine is in column 7. It wants to gain 1 electron to be like argon in column 8, so that would be a minus charge. So they have the same numerical value, so you would just drop those charges and it's KCl. Right, lithium phosphide is the next one. Lithium is here in column 1, so what kind of charge would it develop? All right, it'd be a +1 charge in column 1. Phosphide, phosphorus, non-metal, it wants to gain 1, 2, 3 electrons, okay, to be like argon. So if it gained 3 electrons, it would have a 3- charge. So after we bring that 3 down here and that 1 down here, it would be Li 3P. All right, barium nitride. So barium, got to find that on the periodic table. Barium's in column 2. It's a metal, wants to give up those 2 electrons since it's a metal. So if it gave up 2 electrons, it'd have a 2+ charge. Nitrogen, just like phosphorus, is in column 5. It wants to gain 1, 2, 3 electrons. Remember, nonmetals want to gain. If it gains 3 negative charges, it would have a 3- charge. So that would be, after we switch, the big switcheroo, it'd be Ba3 N2. All right, aluminum iodide. Aluminum is a metal. In column 3, metals want to give up electrons, so it wants to give up those 3 valence electrons. If it does, it'll have a 3+ charge. Iodine in column 7 wants to gain 1 electron. If it gains a single electron, it would be minus. So after we make those superscripts into subscripts, it would be Ali3. And then iron 2 nitride. Iron is a transition metal. It's not in S block or P block, so we don't know exactly how many valence electrons it has. In this particular case, this particular version of iron has 2 valence electrons, so it wants to give those 2 up, being a metal. The Roman numeral tells you. Nitrogen, we just talked about how that's in column 5, wants to gain 3 electrons. All right, so that would be Fe3N2 after we bring that 3 down here and the 2 down here. All right, number 1, very, very important. You will have to do this on the test numerous times. So make sure you understand this. Make sure you practice these. All right, number 2 says, order the following atoms in terms of increasing ionization potential. Okay, so ionization potential. So we have rhodium, sulfur, aluminum, tantalum. Ionization potential is the energy that an atom holds on to its electrons. All right, the energy needed to take away an electron from an atom. So how tightly is an atom holding on to its own electrons? Well, if you think of the periodic table as just a rectangle, and this is ionization potential, okay? It increases from bottom to top and from left to right. So fluorine up in the top right corner has the highest ionization potential, and francium down in the lower left corner has the lowest ionization potential. Okay, so if we go from least to most, increasing, we have rhodium. All right, so let's find rhodium. Rhodium is number 45. Sulfur, number 16. Aluminum, number 13. And then tantalum. Tantalum is, goodness, where's tantalum? 73. All right, so of those 4, tantalum would have the least. Then we would go to rhodium, and then we would go to aluminum, and then sulfur. So if you could write it out like this on the test, it would help me. Tantalum, then rhodium, then aluminum, then sulfur. All right, number 3 says, order the following in terms of decreasing. So that's the most to the least. You got to read the question carefully. Decreasing electronegativity. So electronegativity is, basically think of it as the desire for another atom's electrons. How much do they try to gain another atom's electrons? And electronegativity is just like ionization potential on the periodic table. Okay, it increases as we go bottom to top and left to right. So fluorine has the most, francium down here has the least. This time we're going, though the question says go from most to least. Okay, so our elements that we're looking at are lanthanum, cesium, cadmium, and tellurium. Okay, so let's find those. So lanthanum, goodness, well, that's down here. So it's going to have a low electronegativity. Cesium, way over here, also very low. Cadmium is over here. So we're increasing in electronegativity with cadmium. And then tellurium, even more electronegativity. So in this case, it says go from most to least. So the most would be the furthest to the right, tellurium. Then cadmium. Then the next would be lanthanum, and then cesium. number 4. It says, order the following in terms of decreasing atomic radius. All right, decreasing. All right, atomic radius is the opposite of the other two. The smallest atoms are in the top right, and the biggest atoms are in the bottom left. Okay, so fluorine is the smallest. Francium down here is the biggest. Down here in the corner. We are supposed to order them from in decreasing atomic radius. So the biggest to smallest. And we're looking at rubidium, sodium, oxygen, and barium. All right. Biggest to smallest. Okay, well, rubidium is over here. That's pretty big. Sodium also pretty big. Not as big as rubidium because it gets bigger as you go down, but sodium pretty big. Oxygen way over here, small. And boron also small. Oxygen's going to be the smallest. So reading the question again, we're going from the biggest to the smallest. So the biggest is going to be rubidium. Then sodium would be the next biggest. Then boron. And then oxygen would be the smallest. All right, pause the video if you need to, and we'll move on to the next one. Okay, number 5 says we're going ionization potential again. So remember ionization potential. So if you want, why don't you pause the video and work 5, 6, and 7 yourself and see what you get, and then hit play and see if you got them right. So for ionization potential, we increase going up and increase going to the right. Okay, so we have tungsten, antimony, platinum, and chlorine. Okay, looking at those 4, finding those 4, tungsten is here, pretty low ionization potential, right? It's pretty far down, pretty far to the left. Antimony's way over here, pretty high ionization potential. Platinum right here, well, it's somewhere in between antimony and tungsten. And then chlorine's going to have a really high ionization potential. So it says from order in terms of decreasing the most to the least. Well, the most would be chlorine, and next would be antimony, then platinum, and then the last, most to least, the last in ionization potential would be tungsten. It's the farthest down and to the left. All right, 6, zirconium, rutherfordium, titanium, and hafnium. This one is about atomic radius. So remember, smallest is in the top right, biggest is in the bottom left. So we're increasing as we go to the left and down, opposite ionization potential. Okay, so we are ordering smallest to largest, least to most. So of those 4, see, let's find them. Zirconium, pretty big, it's down here pretty far. All right, rutherfordium, even bigger than zirconium. Titanium, all right, titanium up here, and then hafnium here. Oh, we're all in the same column. Okay, so we are going, let me read again, the smallest to the largest, least to most. So we just have to follow that column. So it'll be titanium, it's the furthest up, then zirconium, then hafnium, then rutherfordium. All right, number 7, last one of these. See if you got it right. Hopefully you paused the video and tried it on your own. We're going with electronegativity, iron, chromium, calcium, and selenium. So electronegativity, draw out that periodic table. Remember, it's like ionization potential. Desire for another atom's electrons, okay? How much energy does it expend to grab another atom's electrons? The most is fluorine, the least francium. Now we are ordering from least to most, so increasing. So let's look at the periodic table for iron. Iron is number 26, so kind of in the middle. Chromium 24, that's going to have less electronegativity than iron. Calcium even less. And then selenium way over here. So selenium would have the most of that bunch. Okay, so increasing least to most. So the least would be the furthest to the left, and that is going to be calcium. The next one to the left is, of those, let's see, it's going to be chromium, then iron, and then the most would be selenium. So selenium's grabbing electrons a whole lot harder than calcium. All right, so pause if you're still writing, and then we'll finish this video up with number 8. All right, number 8, we're going to draw Lewis structures. Now, these Lewis structures aren't going to have the geometric shapes that we do in Chapter 9. Okay, so first one is CF2BR2. All right, carbon in column 4. Now, I'm just doing this preliminary. You don't have to draw the dots like this. I'm just reminding you how to do this. Fluorine's in column 7, so it has 7 valence electrons. Bromine is in column 7, so it has 7 valence electrons. So fluorine can take a single bond. It only has 1 open slot. Bromine can take a single bond. It only has 1 open slot, but there's 2 of each. The atom with the most unpaired electrons, that's carbon, goes in the center. Carbon's always going to go into the center. So we would have something like this. Let's not worry about the shape. I know you probably know what the shape is, but you don't have to do that right now. We do have to draw all the electrons. Remember, bromine and fluorine can only take a single bond. There's 2 each. So you'll have a single bond. And now how do we check? We count them up. Fluorine wants 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Remember, each line counts as 2. 2, 4, 6, 8. All right, let's do B. That's going to be SPI. All right, sulfur's in column 6. Phosphorus is in column 5, so it only has 1, 2, 3, 4, 5. Iodine is in column 7. Now, sometimes students, I ask them to draw the Lewis structure of this compound, and they just draw this. This isn't the Lewis structure. This is just the electron dot diagram for each one. So don't accidentally do that. We have to draw bonds in between these. This is a formula, not just individual atoms. So which goes in the center? It's the one with the most unpaired electrons, which is phosphorus. It has 3 unpaired electrons. What kind of bond can iodine take? It can take a single bond. All right? So that'll be I. Just a single bond. All right? And then sulfur can take a double bond. Okay, so it still has those 2 pairs, but those 2 singles electrons will bond with 2 of the singles on phosphorus. Don't forget those 2 pairs you have to draw. And then phosphorus has 1 pair that's left. I'll put it right there. So count them up, 2, 4, 6, 8. 2, 4, 6, 8 for phosphorus, and then 2, 4, 6, 8 for sulfur. All right, we've got 2 more to draw, and then this video will be complete. All right, we have C and F. Now remember carbon, now you don't have to draw these dot diagrams if you don't want to. I'm doing it for illustrative purposes. Carbon's in column 4, nitrogen column 5, so there's the 5. Fluorine's in column 7. All right, carbon goes in the center. What kind of bond can nitrogen take? Well, it can take a triple bond. It can bond with 3 of these. All right, so triple bond with nitrogen. What kind of bond can fluorine take? Just a single bond. So we can draw it like that. Don't forget that electron pair of nitrogen. You don't forget that. You need to draw that. Count them up. 2, 4, 6, 8. 2, 4, 6, 8 for carbon. 2, 4, 6, 8 for fluorine. All right, the last one is Pi3. Phosphorus in column 5. There's 3 iodines in column 7. I just find them on the periodic table. I've kind of learned them over the years. So what kind of bond can iodine take? Well, it just has 1 open slot, so a single bond. We know the phosphorus will go in the center. It has 3 unpaired electrons, has the most. So we can draw that like this. Don't forget that pair for phosphorus. We need to draw that pair there, and then draw all the electrons. Now, tomorrow's video will worry about the shape, not on today's video. So the homework is the extra practice problems for chapter 8. All right, so hopefully that reminded you how to work all these problems, and you'll be able to just fly through the homework assignment, and I will talk to you tomorrow.